Hello my dear friends, welcome to our channel. So in this today lecture we are going to speak about quantization of charge. So it's a new concept, and here if you know the quantization of charge concept very thoroughly, you can try to solve this problem. Now I'm going to take the concept of quantization of charge. So what do you mean by quantization? So anything available in fixed amount, anything available in fixed amount. So for example, I'm having one pen, so I can buy one pen, two pen, three pen, four pen. I cannot buy half the pen, 3/2 pen. Alright, so I can buy 1, 2, 3 and 4. That means I can buy in positive integers. Right, so that means my pen is quantized. Like that, I can buy one board, two board, three board, four board. That means this board is also quantized. Like the same, from the heading we can say that the charge is quantized. So here I am just going to give you a small information that the smallest charge that can exist independently, is a charge of an electron. Is a charge of an electron. So as you can see here, I wrote one definition here, that is the smallest charge that can exist independently is the charge of an electron. See, there are so many small charges are there. For example, you can take quarks and antiquarks. Quarks and antiquarks, they are smaller than the electrons. These are smaller than the electrons, but they are not having the ability to exist independently. They are dependent on other particles. But here this electron is having the ability to exist independently. That is why we are considering the electron as an smallest charge. That is why we are even calling the electron as an fundamental charge. Right? Even the electron is known as fundamental charge. Right, what is the value of an electron? One electron is equal to 1.6 into 10 to the power minus 19 coulomb, and it's a very vital information, essential information. You have to read this one electron value, 1 coulomb of that means 1.6 into 10 to the power minus 19 coulomb of charge. One electron has 1.6 into 10 to the power minus 19 coulomb of charge. Right, now moving to the definition of the quantization of charge. So here I am having two bodies. Right, I'm just, what I'm doing is that I'm rubbing these two bodies together. As soon as I started to rub together, what will happen is that thermal energy will be produced. Then the surface electrons will utilize this thermal energy and comes out from the surface and enters into the other body. Right, that means this body can lose one electron, can lose two electrons, can lose three electrons, can lose like that n number of electrons, but that n should be an integer. Right, like the same, this body can gain one electron, this body can gain two electrons, this body can gain three electrons, n number of electrons it can gain, but the n should be integer. That means this body has now charge q is equal to plus Ne. Why I wrote q is, this body is having a charge of plus Ne. Why? Because n is an integer. Right, it is going to get a charge of 1e or 2e or 3e. Just because it is losing an electron, it is going to get a positive charge. As it is gaining an electron, it will become q is equal to minus Ne. Right, so I have here two formulas, so I'm just going to write it in a single formula. As you can see here right now, q is equal to plus or minus Ne. It is a quantization of charge formula. Q is nothing but charge on a body, N is the integer, and E is the fundamental charge. And what is the value of E? 1.6 into 10 to the power minus 19. So now this formula I am going to write it as a statement. You can see here my second point, that the charge always exist as an integral multiple. See, it is in the multiplication, so I'm going to write integral multiple of fundamental charge. I can call the E as fundamental charge because it is the smallest charge which is existing in this universe, right? Charge always exists as an integral multiple of fundamental charge, because this charge is only having the ability to exist independently. So this is all about the information for the concept of quantization of charge. So we just have to remember this formula from quantization of charge, that is Q is equal to plus or minus Ne. Now we are going to do a problem. Here is the problem. A conductor has 14.4 into 10 to the power minus 19 coulomb positive charge, right? Here it is a conductor having a charge of 14.4 into 10 to the power minus 19 coulomb, right? The conductor has 9 electrons in excess, 27 electrons in short, 27 electrons in excess, 9 electrons in short, right? So from the question I seen it is a positive charge. When we will say the body is having a positive charge, when the body loses electrons. So once the body loses an electron, what will happen? If this body is losing electrons, that means here there is the deficiency of electron. It is losing an electron, so deficiency of the electron started here. That means here electron is not going to be excess. Here electrons are going to be short because it is going to lose the electron to get a positive charge. If you want to get a positive charge on a body, the body has to lose an electron, right? So here the electrons are not going to be excess, so this option is got eliminated, and on this option 2 got eliminated. So here we are having two options. So how to decide? We know the formula, Q is equal to Ne, right? And what is the value of Q? 14.4 into 10 to the power minus 19 is equal to N into electron, that is 1.6 into 10 to the power minus 19, right? So as you can see here, it is 10 to the power minus 19, 10 to the power minus 19 getting cancelled out each other, right? So N is equal to 14.4 upon 1.6, right? So N is equal to, I'm multiplying by 10, dividing by 10, so N is equal to 144 by 16, it is nothing but 9, and therefore N is equal to 9, that means 9 electrons are short, 9 electrons in short, right? That means this body is losing how many electrons? 9 electrons. Once this body loses 9 electrons, it will get a charge of plus 14.4 into 10 to the power minus 19 coulomb, right? So our option is D. Now coming to the question which I have given earlier, if 10 to the power 9 electrons move out of a body, if 10 to the power 9 electrons, a body is there, from this body 10 to the power 9 electrons are coming out every second, I think, moving out of a body to another body every second. So each and every move, for 1 second it is losing 10 to the power 9 electrons. So for 1 second how much charge is getting, how much charge this body is getting, right? Q is equal to N into 10 to the power 9 and E is 1.6 into 10 to the power minus 19, right? Therefore Q is equal to 1.6 into 10 to the power minus 10 coulomb. So in 1 second, right, as it is losing 10 to the power 9 electrons, it is getting a charge of 1.6 into 10 to the power minus 10 coulomb of charge. So here the question is, how much time is required to get a total charge of 1 coulomb on other body? How much time is required, right? So we should have to create 1 coulomb of charge, right? We should have to create 1 coulomb of charge. How can we create 1 coulomb of charge? Let us see here. In 1 second, it is getting, this body is getting charged by 1.6 into 10 to the power minus 10 coulomb. So in t seconds the body should be get charged by 1 coulomb. So I'm just going to do this cross multiplication. Therefore I can write it as T is equal to T is equal to 1 upon 1.6 into 10 to the power minus 10, right? Therefore I can write it as 10 to the power minus 10. If once it goes to the numerator, it will become 10 to the power plus 10. All right, 10 to the power plus 10. Here I am multiplying by 10 and dividing by 10. It will become 10 by 16. 10 by 16 of 10 to the power 10. It will become 2 5s, 2 8s, right? So 8 ones, 0 point, it will become 50. So 8 6 48, remaining 2, 8 2s are 16, remaining 4, 8 5s 40. So here the answer will be T is equal to 6.25 into 10 to the power 9 seconds, right? Here it is 0.625. I can write this as 10 to the power 9 into 10. So if I multiply 0.625 into 10, it will become 6.25 into 10 to the power 9 seconds. So here the time taken to create a 1 coulomb of charge on the other body is 6.25 into 10 to the power 9 seconds. So in the next lecture we will be discussing the Coulomb's law. So if you liked this video, then do subscribe, comment and share it with your friends.